Hello, Tom from Every Step Calculus, everystepphysics.com. A related rates problem in calculus regarding a ladder and a wall. These are done quite extensively, related rates problem, because calculus tries to make you believe that they solve important things, and it doesn't, in my ways, after 20 years of doing this. I'll read it here. A 20-foot ladder is leaned against the wall. The ladder falls down the wall at a controlled rate of 1.5 feet per second. When the base of the ladder is 10 feet from the base of the wall, how fast is the base of the ladder moving away from the wall? One of these important things for your job in the future. Let's do it. Index 8 to get to my menu. I'm going to go up on the menu to get down to the bottom W's so we can scroll up to the R section, which is closer to the W than the A section of alphabets. And I'm going to scroll here to related rates. Very good. And we're going to scroll down here to ladders and walls. And we're asked to find the base moving, which is along the ground. That's like a right triangle, okay? You got the X and Y axis in a graph, and the X axis is along the ground, okay? So we're finding how far that's moving away from the wall, so it's dxdt with respect to time. And we're given that the ladder's moving 1.5 feet per second down the wall, so that's dy dt, the y-axis, up and down, right? And we have to press alpha before you enter anything in these entry lines here. So we're going to enter the variable given, 1.5 feet per second. I always give you a chance to change in case you made a mistake. I say it's okay here now. And we're going to add the variable for the ladder length. And the length is given as alpha 20, the ladder. Now that's the hypotenuse, of course. I say that's okay. And the distance ladder is from the wall. They give you other things like from the ground also, but this one gives us as away from the wall. So we're going to enter that, choose that, and then we're going to enter what they give us, which is alpha 10 feet. So x equals 10 feet. That's along the ground here, x-axis on a graph. Say that's okay. First we find the amount for the y, and we're going to solve for y, and y equals 17.321. We're using the Pythagorean theorem here, x squared plus y squared equals z squared, and then solving for y, okay? And we're going to find dxdt, so we're going to use the Pythagorean theorem. We're going to differentiate it, put 20 here for the z, which turns out to be 0. So then you differentiate 2x, derivative of x squared is 2x, dx dt, derivative of y squared is 2y, dy dt, equals 0. Now we enter what we know, which is x is equal to 10, and dx dt is equal to 1.5. No, dy dt is equal to 1.5 here. And you do the calculations, 20 dx dt plus 52 equals 0. Of course, we use algebra. Minus 52 on the right side, 20 dx dt on the left side, and we solve for, turns out to be minus 2.5981 feet per second. Pretty neat, huh? everystepcalculus.com. Go to my site. Buy my programs, and believe me, you'll love them, and they'll certainly help you pass calculus, which is what we want to do, get out of there and get on with our lives. Such a worthless subject. All right, have a good one.